Hello, listeners, and welcome back to the Peggy Smedley Show. As always, I'm your host, Peggy Smedley. We're taking a closer look at one of the most important developments shaping the future of AI and infrastructure, the Model Context Protocol, otherwise known as MCP. As AI moves deeper into engineering and operations, the real challenge isn't generating answers, it's grounding those answers into the right data, the right context, and the right safeguards. MCP is emerging as the key to making AI not just powerful, but truly trustworthy for the people who design, build, and maintain our critical infrastructure. Joining me today is Francois Valois, who is the Senior Vice President of Bentley Open Applications at Bentley Systems. Francois, welcome to the show.
Thank you so much, Ian. Delighted to be on your show. And then hello, everyone. It's going to be a fun conversation, I'm sure.
It's an interesting time. Everybody's talking about AI. Everybody's pushing for it. But for those who are trying to understand, and I thought it would be really interesting for us to talk about what is MCP, Model Context Protocol. I talked about it in the intro. And why has it become so important for making AI useful? And more importantly, I'm thinking about it as trustworthy. This is a very important part of the conversation we have to have, especially when we're talking about engineering, we're talking about engineering workflows. I thought maybe that's a great place for you and I to start our conversation today.
Yeah, great question there, Peggy. Model Context Protocol is an open model agnostic standard that is being invented by Anthropic recently that really connects different types of technology and engines to the large language model technology that we can see. So it's really unlocking a lot of value on the agentic workflow. And so it's the agentic foundation providing the deterministic answer. So the right answer, the 99.9, 100% accurate answer to non-deterministic generative AI, such as ChatGPT or Claude and so on. So really connecting these two worlds and exposing the engineering engines to these smart generative AI tools. I think the very simple analogy around MCP is think about it as the resume of a piece of technology. So my resume says that I'm SVP at Bentley. I can do and have the following skills and explaining to somebody what I'm doing. And then from there, if you want to hire me to do something, you know what I'm doing, and then you therefore be able to have a contract and then do something with me. So that sort of is a good analogy here. So this Model Context Protocol was invented less than 2 years ago by Anthropic. And it's a beauty of technology because it's so simple. And that's why it took the market by storm. So it's basically saying, okay, if I'm going to use the example of, let's say, our calculation engine that does any types of analysis. This calculation engine is able to say, calculate the load of something or make this sort of design. Then it's able to, the MCP basically says, I'm calculation engine ABC, and I can do 1, 2, 3. And this is the resume or the visit card of that technology. And this is basically then making it possible for any GPT-style engine, agentic workflows. So that could be Claude, that could be ChatGPT, that could be Copilot, and they all support what's called MCP server capabilities. So they're able to say, knowing, so as you expose those MCP to those agentic tools, they're basically able to say, okay, I know I have this task to be doing. Somebody's asking me design something or do that thing. And then I'm able to know that I have a new friend, a new delegate, a new employee, I know the resume of that piece of software that does that calculation. So it's just delegating the work to that. And then this thing is doing the calculation and return back an answer. And then the agentic workflow is then able to say, okay, what do I do with that now? That answer. And then based on instruction provided to this. So it makes it really simple to interact with and avoid hallucination and that sort of thing. Just really make sure that these agentic workflows can have access to deterministic output and really are able to get the right answer to complex question by leveraging software that have been doing this sort of work for years.
So you make a good point. It's been doing it for years. So then why should infrastructure professionals care about this now? What does MCP unlock? directly that impacts how we design or operate or maintain critical infrastructure. When I say that, I know what the answer is going to be, but how do we get people to understand that we're entering this new era of work?
So I think there's such a wide gap in between our ability to design, build, and operate infrastructure compared to the need of society. So we have that big gaps, and we have the gaps of the workforce challenges. Those are not new, but with this sort of technology, it really helps filling that gap. And let me explain what I mean by that. A lot of people that I meet around the world, and everybody's looking at how can I be more effective at providing my clients, or maybe I'm the owner of providing design to my citizens. And then to do that, you need to get gain in productivity. And that's what these GPT style engine can do. What do they allow to do? They allow to simplify access to technology by simply talking to it. But also you can create these, what people, it's a term that a lot of people use, but agent, right? So an agent will be a large language model combined with some abilities. They're called skills. So you combine those things, and then they're then suddenly able to do things that you would normally do by hand. And so you can delegate some of the work to your agents. And there's a lot of parallel to be drawn between software development and engineering. In software development, this day and age, at Bentley or any other software development company, we all use agents. So a software developer now is somebody that doesn't need to be the best at writing code, but needs to be the best at designing a complex architecture that needs to be able to understand the result of an AI providing the code, needs to be able to understand the intent as to what they want to do. So the skills is the same, except that you're removing the tedious part, which is just typing the text, typing the code. And so essentially, this is what this is about. It's essentially the human is still in control of the workflow, and it's enabling this additional level of automation, and through MCP, delegating to tools that are really good at calculation and doing complex things, which these GPT things are not. They're really not great at it. Calculation for a large language model is terrible at it. And they're also non-deterministic. They're basically, I'm sure all the audience have been using this sort of technology. You can ask it to create text, and it's going to create 5 different versions, or as many versions as you ask. So it's just based on statistics. And in our field, so us and the audience, that's not acceptable. A 90% bridge design is not a bridge design. You need to be 99.9% sure that this bridge won't collapse. And so this is why you want to combine the power of agentic workflow. It's really good at bringing the context, automating some of those things, with the deterministic power of tools exposed to MCP through these agents.
I'll bet you everybody listening wants to hear you say not 99.9%, 100% perfect on that bridge design, because every time we go over that bridge, we want to know we are safe as the day is long. I love to hear you say that, because I think sometimes we lose sight of just exactly the things that we're building. And I think the important thing that you talk about in infrastructure, it's everything until there's a crisis. Until something happens, we forget how important some of this critical infrastructure really is. And so you talk about human in control is so critical. So we need AI, but I think that's why it's so important. And Bentley really talks about this for long advocated about open ecosystems, interoperability. And this is where I want you to talk about, because you talked about some things that are terrible, and you really were very frank about that. And I appreciated hearing you say that. But I think what's important here is talking about how MCP fits in with Bentley's broader strategy, because it's around open applications and connected infrastructure data, but letting companies understand that's where they shine with each company that does what they do best.
Yeah, exactly. I think you said it very well. Openness at Bentley is non-negotiable. The name of my group is called Open Application, just that it's in the name. But also that's one telling system. But the most important thing is that a big part of our software is open source. Open source and available, so open format, open source. So we've been building the iTwin platform for a long time. We just made the acquisition of Cesium in that context, which is the world leader in open standard for displaying data on the web. And openness is super important. Why is that? because we understand that Bentley is not alone, that we work in an ecosystem of various connected tools and technology and people that are, and processes that are really driving our end users, our accounts to do their work every day. So we understand that we cannot be the only one. But the other thing that we understand is this life cycle of infrastructure is really long, right? Design might last a year or so or less, but then construction will go on for a few years and then operation for 30 years. And having your data and locked in by a vendor is unacceptable, because you need to be able to get access to your data at all time. You need to be able to read it in 20 years from now. And so you need to be able to write a program at the very least to be able to extract access to your data. So that's why we created, and that our strategy is all about this open data, open source. MCP is part of that strategy, right? It's not only are we opening our data, but we're also opening our tools to the rest of the world in the context of saying, okay, now if you have a calculation engine, and we just recently released 2 MCP, MicroStation and STAAD. Those are really strong tools in our portfolio. MicroStation has got hundreds of thousands of users, and STAAD the same. If you go to India, STAAD is, if you talk about STAAD in India, you're a superstar, right? Everybody's using STAAD over there. And it's really important because for a lot of time, tens of years, these engines and things have been providing services. By opening this up to agentic use cases and workflows, we're now making it possible for people to automate their work while still controlling to get to the 99.9 or 100% accuracy that they need to meet their task. Because as you said, we're working in critical infrastructure, lives are at stake here and the things that we do. And we take that responsibility super, super strongly and super seriously. Yeah.
Let's go into deeper detail about STAAD, because I think that's important. Because how does Bentley ensure, because this is that critical conversation again, and I think it's really important about trust, validation, accountability at every step of the engineering workflow. You can't skip that. And I think for someone listening, they want to know how they can be that superstar that you just described. I think that's the power here.
Absolutely. So STAAD as a name is recognized in the industry as a trusted calculation engine for structures. It was used, for example, for a few years ago in Singapore in the Mandalay Bay Hotel, which I think you were there for one of our conferences.
Right? I love that. Yes.
So this was calculated with STAAD. At that time, of course, agentic workflows did not exist. Agents and AI was just a dream, all those things. And some people will work on that. But still, the idea was not there. But that STAAD was there. And then there's been that trusted engine of ensuring. And then how do you gain that trust is years and years of reliable results that can be verified. Here's my input, here's my output. And then if you have the same input, it's going to always provide the same output. And with tools like STAAD, we are, for example, nuclear certified. So we work with nuclear industry in the US and in Canada, and we have these very rigorous QA/QC for structural calculation in the nuclear sector. Think about the impact of if something goes wrong, what sort of thing can be happening here. And STAAD is used, and STAAD and our structural products are used in, of course, building design, in oil and gas, in nuclear, in bridges, many things. So it's that long-term trusted engine with all of that, these things, that the issues that maybe 10 years ago that is now addressed. And then we have automated tests to keep it always running and running. And so I read an article on that. I don't know if you read that one, but it talked about the rise of the incumbent and this sort of us, people that have these very strategic engines. And then in a world of agentic, and basically saying, look, this code base is really hard to replicate. It's actually really hard. Because even if you were going to read all the textbook of structural engineering in the world through AI and then generate a code base, it still things that it doesn't cover in the textbook. And there's going to be hundreds and thousands of cases that are not in the textbook that the AI was not able to catch. And so that's why leveraging these engines in the calculation and in an agentic workflow is just so powerful. And it's going to basically see a lot of usage in a lot of different contexts. And this is just the beginning. And also what's also important is that it's not only about Bentley. MCP is for everybody. Some of our competitors, such as Autodesk, Esri, and others, are essentially building those things. So that means for firms and owners, operators out there, they're able to combine some of those, which I think this is the real value. It's not one MCP, it's multiple. And then having that coordination being done through these agentic orchestrating tools that are essentially be able to say, okay, here's the task at hand. Maybe I grab some data from my enterprise system. my email or my spreadsheet or an SAP or Salesforce, and I do something with it. And then at some point it says, okay, now in this workflow, I need to calculate a structural analysis engine. By the way, I know about someone that can do that, STAAD MCP. And then if I can send the workday and the result come back, and maybe I take that and then I take that result and use it in Revit and do something. These sort of combined use cases and this integrated things is quite important. And the role of platforms like the iTwin platform and that structuring that data is also important because your end results and your calculations and things like that will be only as good as the data you put in there. So structuring your data, and if you've been following Bentley sort of a conversation for a few years, you'll know that we've been talking about exposing dark data that might be locked in different files and so on, right? Exposing that dark data and make it accessible and visible. That's a foundational layer now that we have that you can build from and on top of.
Let's go back a little bit. I know we're running over time, but I want us to take the time. For those listeners who are trying to understand, and if you have the time to stay with me, I want to kind of peel back the onion, so to speak, here for us. What role, when we talk about this structured data, does it play in making MCP and AI, a little bit these agents, actually play with this kind of, I guess you'd say, infrastructure workflows that we're talking about? You've talked a little bit about it, but help us really understand what that means for someone who's saying, how do I start with this? I'm trying to understand. I want to be that superstar engineer that lights up my company. I want to design this so that I know what I'm doing. So how do you actually make it useful and go from there?
Yeah, I'm a huge believer. I'm a surveyor by training, right? And I'm a huge believer of engineers understanding data and embracing data, which is not always the case, right? It's an evolution there for our profession there. But understanding
data. You started with
when
dark data, right? You said there's dark data and we want good data.
Yeah.
We don't want.
Exactly. So understanding that data is oil is super important. That's your asset. And then you need to make choices that makes that data not only useful for creative drawing, but you need to be able to use it downstream, right? So if you're designing a road, you need to say that data that I'm creating here, it's not a drawing, it's actually data that can be used in the construction and so on. And then you need to structure that. You need to expose it in a way that's going to be standard. And that's why
Can you also ask one more thing? So again, for someone listening, it's not that it's all the data. There's some data that's better than other data. And so for those listening, because we get lost in the idea, we've got all this data, you got to use the right data. And that's maybe where AI is really helpful here. And you've talked a lot about that. So for someone listening, they have to be intuitive enough to use AI to help them. That's where the agents are coming in, to know how to separate what you're doing and then being able to replicate that for the next things they're doing. And that's what we're talking about.
Yes, no, exactly. So it's mobility of data across the phases, but it's also exposing that data to AI agents so it can make better decisions. Because of course it's smart, but it's not infinitely smart. So it cannot really understand things that are not well structured and well understood. And so that's really important to structure that data. Bentley has came up with a concept of base infrastructure schema within the iTwin platform that is then allowing so we have multiple connectors as well with a lot of different tools. We have tens of connectors that allow to centralize that data there, make it semantically rich. That means smart becomes from dark data to smart data. And then that becomes a well of information for AI to make decisions on and then be exploited. AI can also help structure that data, which is also something that is quite interesting. So able to, for example, take reality data, but some of your listeners are very interested in too. So how do I segregate, how do I classify, how do I identify things within drone information and so on. So that's been something in the computer vision type of thing. And now it's able to do that as well with structured data. It's very good at mapping different types of schema, that sort of thing. So it's helping a lot with that data engineering, I'm going to call that, and that focusing that data, making it available for downstream consumption, but also exposing it, making semantically rich will help with the AI itself to be smarter and help you even more to augment the engineer, which is fundamentally what we want to do, is augment the engineer. We don't believe that engineer will be replaced by AI, but it will be augmenting what they do and then being able to close that infrastructure gap that we're all part of. Yeah.
But that's a great point you make. How do you see the relationship between engineers and AI evolving in the next few years? Because we see a lot of people concerned. Are we still going to need them? How do you see that changing?
Yeah, I mean, I tell you, I'm not a futurist, right? So I cannot really predict the future, but I can tell you that I think it's really augmenting the engineer and not replacing them. And the gap is so big that if we can just fill the gap. And I was talking to my software developer because I think there's a lot of parallel between software development and engineering. And people are like, oh, is there a problem for software developers? No, because it's never happened to me that I meet one of them of the account that I work with that I was able to fulfill all their needs. It never happened in 21 years at Bentley, right? So maybe I'm able to now be the bigger percentage of their need. Maybe I'm able to provide something more robust, more solid, more modern. I'm able to take things that were not possible to do. Now I can do it. And the same should be in the head of the engineer. It's like, first, number one, embrace it, understand it. What are the limitations? Myself, I'm learning all the time. I just completed another MIT classes on that and understanding even deeper and so on. So embrace that, learn about data, be data savvy in that context, be able to understand the limitation, what it doesn't do. It's not magic, it's just mathematics. All engineers know mathematics, know statistics. So it's like similar things that they've learned in school and so on. So there's that. And then so embrace that and be part of that change and really control that and be in control of the technology. And that's super important. And that is for big firms, small firms, owners. Everybody needs to be engaging with that technology and understand that. And I think everybody does actually. So it's not like people are standing still at all. And I'm a huge believer as well that people are adapting to change. And it will basically, the job that we have today might evolve over time, might become something else. There's things we're doing now that did not exist 15 years ago, right? Doing podcasts was like what you think at that time and so on. So this sort of thing is changing all the time. So huge optimist in that context, and maybe it helps close that infrastructure gap over time. Absolutely.
Do you think one of the biggest risks with AI that it confidently uses the wrong data? Are we making that mistake? How does MCP prevent that? When I hear you talk, I think sometimes we're getting too comfortable with it in some ways where we have to see, because I hear you talk right now and you say you're still learning. Here's somebody that gets it. You understand it. You're very educated, but yet you're still educating yourself. So what safeguards ensure that AI can't bypass governance, I guess is maybe, or pull unvalidated information that we almost get too comfortable with, that we have to make sure we're doing the right things at the right time with the right place?
Yeah, exactly. So AI is augmenting engineers, is augmenting software developers, and that is the key there. When you say that, that means if you want to be augmented and able to be more productive, which in this world you have to, it implies that you understand what you're doing, and it becomes an additional skills that you put in your toolbox. And skills you can learn through the internet and so on. But in this case, I wanted to get more fundamental skills so I have a good understanding of what's producing by AI, what are the limitations, why am I in a dangerous zone, because I want to produce the right outcome, right? And that's really about what the engineer should be doing. I'm a surveyor, I trust, but I verify, right? Double check, triple check things all the time. Because if I say this coordinate is in this spot, it better be, right? Because somebody's else gonna rely on that. And so that double checking, triple checking things is be part of what engineers do. And AI can help with that, but I wouldn't trust that with my eyes closed. I would rather evolve that. And that's also the same with MCP. MCP, while it providing the deterministic outcome, if what came in there was wrong, it's going to provide a deterministic outcome that is wrong still, right? So really harnessing the power of those agentic workflows is really key, and it takes education, it takes time, it takes practice, and people should jump in there, try it, and then really get in the vibe of, people use the term vibe coding, but there's also a thing, vibe engineering, that I think is also quite a keen way of presenting that. But in engineering, we don't want a vibe, we want this 100%, 99.9% accuracy, and that's really key to do that. And MCP is definitely one of the building blocks that is evolving and making that possible, right? So it's not the answer to every problem. It's one of the tools in the toolbox of an engineering team, engineering firm, to really be able to continue competing, providing better outcome to the world, and helping closing the infrastructure gap.
As I was hearing you talk, it made me think about if we were to revisit this conversation in 3 years, maybe sooner, I wondered what would have changed. Will it be that MCP will have adopted infrastructure workflows? What would they look like? Would we be talking a different thing about STAAD? We'd be talking about new partnerships like Cesium? What will have really made mainstream adoption? Will it be the partnerships? What in this marketplace is going to accelerate? Is it AI agents? What do we have an idea? It just seems like there's a lot of moving parts going on right now. And it's when we peel back that onion, there's so much going on that it's almost, we're back to open again.
Yeah, no, exactly. CP is one of the building blocks. It evolved in less than 2 years. What's going to happen in another 2 years, 3 years is really hard to predict. What I can tell you is MCP is here to stay, and there's a lot of adoption of that technology, and that we're building more MCPs. We're going to build MCPs for all of our open applications, for our other tools as well. And it's going to make our portfolio more open, more accessible to AI workflows, and make the industry go faster. But there's going to be also other new trends that are developing, that are being added, because MCP is not the only thing we're doing in AI. We're helping automating mundane tasks to drawing production. Placing text on a piece of paper is something that is not, you're not using your best intelligence doing that. Why not automate that? And we're doing this. And through AI, it becomes possible to understand what is legible and what is beautiful, which was not possible before. So we're doing that. Second thing is we also having these co-pilot capabilities. If you recall, we have these assistant capability within our tools, which are agentic workflows that are really smart. They understand that when you talk to them, they understand how to delegate to the tool. And they're essentially, in this case, we provide the agentic workflow. And then we're doing other things on the design side, leveraging a technique called surrogate AI. We're able to actually create approximation of calculation through AI to really rapidly provide conceptual design tools, which then can be finished into things like STAAD, for example. So this sort of thing, really combining the right tool for the right technique. And the last bit, which is what we've been talking about for the past half an hour, is MCP, which in this case, we call that bring your own agent, bring your own wine type of thing. You're bringing the agent, we'll provide you the infrastructure the infrastructure calculation for your workflow that is maybe integrated across the enterprise. And I think what we're going to see in the future, because talking to engineering firms, these technologies have not happened yet on the production floor, and they're just evolving and everybody is learning. But I bet you in 6 months, 18 months, 24 months, you're going to see that become really more mainstream, on top of other trends that will be invented by the world as we go from there.
Seeing that at a faster pace right now, are you seeing it starting to pick up MCP as the adoption? Engineers are starting to recognize it. Is that what's happening?
Yes. Yes, as we posted our STAAD and MicroStation MCPs on LinkedIn, we had a lot of reaction, a lot of people jumping directly to try that, to understand it. And thanks to people like you, the word is being spread out and people really start to get this. Those MCPs also are available under the Anthropic MCP registry, so people can discover those there. So there's a lot of things happening around here. Yeah.
So looking at it right now, if someone were to come to you and their biggest challenge, what would you tell them? Where do they begin? I always want to leave my podcast with someone saying, where do we start? What's that first thing you got to be thinking about and saying, okay, I'm not just overwhelmed by it, but I feel really good. This is where I should start.
Yeah, I would start by thinking about what the outcome is that I'm designing to do. Then I would install my favorite tool or any tools and then really start experimenting with it. The best way to learn some of those engines in GPT engine, large language model, is to actually talk to those things. And they'll tell you a lot about themselves, right? And how do I do this and that sort of thing. So that's one thing. And then start with a small project that I know maybe a project you've done in the past that you want to do, and repeat, and then build the trust for what you do there. So we're doing it ourselves when we use AI for different things. We first establish, understand, then experiment. And I think I would say my number one advice would be the winning strategy that I've seen that I think is really good is, okay, yeah, the experiment is absolutely key, but do this without having the safeguard upfront. So do this in a experimentation framework on copy data, something where you can really do something different, right? And try something different. And the best companies I've seen, instead of adding a committee with a lot of decision making and so on upfront, they first experiment before they decide. And so they deeply understand what's happening instead of being scared. So the best I've seen, instead of adding committee and committee, they basically have safeguard. They're saying, okay, if we're doing something here and it doesn't go as well as we want, we have a way to go back. So they're really making it available to a large number in the context to experiment, but with safeguard in mind. And I think that's a really winning strategy, because that's how you get the scale and the creativity of everybody to be involved there. But of course, you don't deploy that on your biggest project on day one. That's not what I'm saying, but learn and understand and really have that culture of experimentation. I think it's a really key thing that we don't do enough in engineering, because the creativity and that sort of aspect is super important and can unlock a lot of innovation for sure.
Francois Valois, that is a great piece of advice. Senior Vice President of Open Applications at Bentley Systems. Thank you for your time today. Where can our listeners go to get more information from you or from Bentley on the things that we talked about?
Absolutely. There's one URL that is quite interesting. So infrastructure.ai, and that's going to link you to what Bentley does on the AI front and provides you a lot more information there. We're also available on LinkedIn and all the good social media out there. Peggy, I really want to thank you, and thank you to the audience as well there.
Thank you so much, Francois. Okay, listeners, that is all the time we have for the show today. Make sure to share and subscribe to our episodes each week. Share your thoughts with me on X at Connected World, or follow me on LinkedIn and YouTube and continue the conversation there. Please check out our website at connectedworld.com or our show website at thepeggysmedleyshow.com. Remember, we broadcast live every Tuesday at 12 p.m. Central, and you could check out our podcast every Thursday. This is the Peggy Smedley Show, your voice for our connected world. And remember, with great technology comes great responsibility.